What if you could work with some of the world's most innovative companies, all from the comfort of a remote workplace? Andela has matched thousands of technologists across the globe to their next career adventure. We're empowering new talent worldwide, from Sao Paulo to Egypt and Lagos to Warsaw. Now, the future of work is yours to create. Anytime, anywhere, the world is at your fingertips. This is Andela.
Ahoy there, my name is Savas and I would like to go serverless with you. But before you head out with a total stranger into the cloudy serverless wild, let me introduce myself. I am Savas Ziplies, founder and managing director at Ellipsis and passionate software engineer for over 15 years now. Having worked on research and product developments in multiple areas and industries such as mobile apps, gaming, backend and high available serverless applications. With the advent of DevOps and serverless and the goal to bring devs back again closer to the operation, I would like to show you today how to leverage your daily Go environment and just deploy it serverless from the tip of your finger. So let's start. And let's start with the most important question, why serverless? And this is hard to answer. It's an excellent question, but it's hard to answer. And I hope by the end of this presentation, you will know for yourself if serverless is good for you or even not. But defining serverless is also already hard because serverless can mean a lot. For some people, mobile developers, for example, that just use a backend service like Firebase, it's already serverless because they don't have any server anymore. But this is rather a backend as a service compared to a real serverless vendor function as a service, what we will talk about today. So what we will talk about today is not caring about the infrastructure. So there are servers. In the end, there are servers. It's just a cloud. It's the service of others. But you don't own the service anymore. So you are serverless. And this is the important part. No dedicated servers for you, no dedicated instances for you. You just think about the functions and the functionality that you want to deliver to your app. So you are just simply developing. If we break it down to the 4 pillars for serverless, and for today we're talking about the infrastructure as a service that we want to deploy to. They will care about the high availability and the nearly endless scalability that we want to use. What we deploy only runs when we need it, so we also only pay when we need it. And we just focus completely on the development. We just continue as we did before, develop our application and just care a little bit, tiny little bit about the operations side. So if you look at the market right now, what is there available? You probably heard about Microsoft Azure Functions, you probably heard about AWS Lambda, maybe even Google Cloud Functions, and some might even have heard about IBM Cloud Functions. Why IBM Cloud Functions here? Because it is based on Apache OpenWhisk, which is an open framework that you can potentially also use to deploy a functions as a service on your own Kubernetes cluster or your own server environment or FN project, which provides something similar that you could use. On top of that, there are also other full service providers like Vercel or Netlify, which also have functions as a service, but more abstracted for a web development part. If you really want to deploy pretty much everything, they provide a full service abstracting what is really behind that. So with so much going on, let's just go for it. Let's develop our serverless application. So if you think about it from a architectural perspective, it's pretty simple. We have, for example, our web application, and our web application has some requirements. So we write down the user stories and what we want to develop. So for example, we need to provide the time, we need to update an entry, filter data, search data, yada, yada, yada. So the web application just want to push the requests and get the data that we have stored in a database, for example, from our single functions. If we would now develop this, for example, we have 3 developers picking different user stories. working on the time implementation, the update implementation, the search implementation, and just go ahead, create their functions. One might develop it in TypeScript, the other one might develop it in Go, the other one in Python. So it's pretty flexible and everybody can work in the best environment that they would like to work in. Then everything is deployed. Let's take the example of AWS. You have the different endpoints. So for example, API time, API update, API search, where you can then access from a client perspective the different endpoints and functionality. So client and front-end developer is happy. If we look now what is really happening inside these functions and we take a first close look at the Google Cloud function, then you can see that's basically just a simple function, in this case hello world, that just implements the HTTP handler interface, response writer, request is in there, and then you just go ahead and do whatever you would like. In this case it's pretty simple. You just return your hello name or hello world without any main or anything, and you could just deploy it and have a serverless function on Google Online. For AWS, it's pretty similar. You can also deploy or return a hello world or hello name function, but you have to proxy these requests first, because based on the API gateway by AWS, you have to proxy these into the Lambda handler that is already provided by AWS. So after that, it's pretty much the same as we have seen on Google and with many other providers again. So it's a little bit more complicated compared to some others, but in the end, it's the same. So if we would continue now with the AWS example. So you create just your project, add the AWS Lambda Go library, and add the Lambda start handler as we have seen on the slide before. Then you create your AWS account. You can create a free account. You have a free tier. You have 1 million requests on Lambda that you can execute for free. So just go ahead, just create something. Build your application, install the AWS CLI, zip everything up, create your IAM permissions, because without permissions you cannot invoke or upload anything. Then by creating your function, you're just uploading basically your compiled Go application, push it online, and then you can invoke it. If you invoke it, this example is very creative, you get hello world returned, and you can rinse and repeat function by function, developing your time, update, filter, search, whatever you need. So it's very easy and quick to start, easy in development, function by function. Basically, you could work user story by user story, and you would really follow a single purpose design from the get-go. But as you already have seen, there are already differences only between Google and AWS, and it's similar with other vendors. So you are immediately vendor locked here. And to some occurrences, the single purpose functions might be a little bit too microservice for some development. You just want to think an app, you want to develop an app and not think already from the start in the single functions. On top of that, if you start creating 50 functions, 100 functions, maybe with dependencies to different infrastructure like queues or database or in between, it might become very tedious to develop locally and then especially test it locally if there are some interdependencies. So it's not native to what we are normally used in development. Everything can be covered with structure and with good architectural design, of course, but maybe we just want to stick with what we already know. So these native fast functions, they fulfill their use cases. They have a use case if you really need small, quick, high available functions that you just want to deploy on single clouds and that you just want to incorporate in your existing application. But maybe it's not right for you if you want to develop a whole application. But this is what we want to. So let's go a little bit further. So next level is when we look at our architecture that we have seen as our simple serverless architecture, that we do not think in functions anymore, but think in applications. So we are developing apps because this is what we do. It can be one app, it can be two apps, it can be multiple apps. We can start off with one app and then split it later into multiple apps because of the requirements that we have derived from the execution. You just start really developing and focusing on your application development. So our goal is to reuse existing frameworks and libraries that we already have in our Go environment and that we work with on a daily basis. We want to start simple, so developing just our application, but stay flexible if we might potentially need more or want to split it up. We want to deploy to AWS in our example today, but be flexible to also deploy to others. And we don't want to care about the infrastructure, of course. So I would like to call this now for today a framework as a service approach, to stay with the abbreviation of FAS. We are flexible and extendable by using an existing framework which already has so many plugins, so many modules, so many middleware that we can use. It has all the routing, it has all the JWT authentication, so we don't have to do anything there. We want to be able to develop locally, deploy it in a Docker container, deploy it on our own service, but also be able to deploy it serverless. So development first, operation second. And when we're using a common web framework and a common design pattern, we are also using something that we already know, a structure that we already know. So we are keeping it simple, but serverless. And for the example today, the project structure given today, we are looking at a monolithic microservice architecture. So we are combining the convention and the configuration all together. For the example, I've picked Fiber as an Express.js inspired Golang web framework. Very fast, very easy to use, and will be incorporated in the example today. This we want to deploy to AWS with AWS Client SAM, and building, testing, and deploying can be done via Docker, of course. So if we look at the project structure that is provided here, it's basically segregated into, I would say, 3 or 4 parts. So we have the build part. The build part is where the build configurations for the different providers are in there. In our case, AWS. Then the most important part is the command part. This is where our serverless apps really live in. We have our API, a queue handler, for example, a web API, or whatever we need. All our serverless applications live in the command area and are fully fledged applications. On top of that, we can add any common code. So for example, models or helper functions that we want to share between our different commands, and then some additional files like environment, Docker Compose, and so on. I won't go through all the different code lines, as those are just normal Go projects. So I provided a GitHub repository which you can check out yourself and see if everything works out for you too. So if we look closer at one of the commands, for example, the API command, it's just a fully fledged app. It serves as its own, it stands on its own. It's just a Go module init app where you can just develop, include Fiber, add your routes, add your middleware, add your database connection, whatever you need, you can add it there. But you can add additional commands, for example. So you could even add vendor-specific commands. So for example, that are stuck to AWS. Everything can be mixed all together. But the important part is you can start simple and extend it later on. You are not locked by anything from the get-go, but you can later on decide, or for example, in this application, I have noticed that this endpoint requires more memory. So I split it up into a different function, which is basically just a new command, split it up, create a new deployment configuration, and you have a new serverless configuration with the according configuration of memory that you require. Now, to handle the different entries coming from AWS or locally or later on GCP or whatever we can think of, we want to create a single point of entry, which is in our case our main Go file, where we just basically import a new environment variable, in our case server environment, to decide where we are running. In this case, if we're running on AWS, we start the Lambda handler that we have seen earlier. If we are not in any specific server environment, we are just starting a normal Fiber local web server and can just test it or deploy it however we like it. So we have a single point of code and a single point of entry here. For AWS, as mentioned, we need to add a little bit more as we have to proxy the requests into Fiber. But it's quite easy, as AWS provides everything themselves. So AWS Lambda Go API proxy is a GitHub repository which provides adapters that can be attached to Fiber, but also Gin or Echo and other web frameworks. So based on our server environment, we just init it, attach it, proxy our context, and we are back into our normal Fiber context. And everything after that is just normal development as we know it. And this is why we just develop. So we are not caring about serverless. We are not caring about AWS. We are not caring about GCP. And this is the goal. We just want to develop, test, and everything that works locally should just work automatically serverless, but be high available and scalable on the cloud, available for everybody. So just develop, finish your app. And when you're ready, we're bringing it to the cloud. Now we're really going serverless. So we already have our build structure, we have our commands. Now we want to bring it to AWS. How do we bring it to AWS? By using AWS SAM. SAM stands for Serverless Application Model. And the name already gives it away. It's an application modeling. So we are not modeling an infrastructure, but we are modeling our services. We are modeling our application as a service online. So it serves as an ops layer between our app that we have developed locally and the serverless deployment in the end. You can just install the AWS SAM CLI, init it, can select from different templates, zip your artifacts or create, for example, containers via an ECR on AWS, for example. You select Go, as your programming language in our case, and just create your application. SAM takes care about everything. It creates the folders, it creates the configuration, and theoretically, you could just call SAM build. It builds and zips your the initial template that has been created, then calls SAM deploy and just deploy it to your configured AWS account. And suddenly you have your first serverless application online running. With SAM deploy guided, you get even asked the important questions, what you want to do, where you want to host it, which region, for example, and you can configure everything from the tip of your fingers. And this is what we want to. But as we have our own structure with applications and not single functions, which would be created if you just call SAM init, we have to adapt it to our project structure. So we just look at a template YAML that is created by SAM, because this is basically the infrastructure as code or the app as code that we are using. In the app as code, in the template YAML, you have resources. And our function, our API function, for example, is a resource. It's an AWS serverless function. But instead of just having single files, we define the URI back to our folder structure where we have our commands and define the whole build as our single function. We can add additional properties like, for example, memory size and timeout. And always remember, you want to always start off low, and the lowest you can run, the cheapest you will end up in the end in a serverless environment. And this is basically all the configuration that we need, that we give away to SAM. And then if we call SAM build and deploy, SAM takes care about the rest. The important part is then, how does our app get called? So we have to add an event. An event is the trigger how our app is invoked. And as our app is a function, we want to attach it to an API resource, and we want to just proxy in all the requests that are coming in and handle it internally. So compared to what we have seen earlier, where we created an API time, API update, API search, for example, we don't split it up because we are doing the handling, not the operations side is doing the handling. So we are just proxying all the requests that are coming in into our own app and handle the rest. On top of that, we have to configure the environment variables, of course, so that we can set the server environment so that our application knows we are running in an AWS environment. And of course, a lot else, because as already mentioned, we are defining resources. So if you define resources like, for example, an RDS database, you can reference the RDS database that you have defined in the same template and just attach it as an environment variable so that you don't have to create anything on an AWS console, copy the URL and paste it in here, and then the URL changes and everything is broken. You just reference your deployments directly here, and AWS SAM and CloudFormation takes care about the rest. So sometimes you might need additional data. So I picked an example that you might need, for example, Chromium to be used by your serverless application because you want to invoke a Chrome instance and then visit a specific website because you need the JavaScript to be called to get some information, for example. To have this running and not necessarily have to build a new container image, you can just add the data as a layer on top of your serverless function. So you would just download whatever data you need, in this case the Chromium build, have it in your build structure, you define where it is lying around with the content URI, and then it is just attached as a serverless layer that is always hooked into the serverless execution function. So every time the function is executed, the data is available that you have uploaded here. And as functions and layers are always versioned, you can always update new versions, for example Chromium, but you could also roll back and switch back and forth. In the end, also already mentioned, you might want to configure databases, DynamoDB, SQS queues, or Redis clustered, whatever you can think of, you can basically configure in this template, because it is a CloudFormation based template, and everything that AWS offers you can configure in this template. So creating an RDS instance, easy. Creating a queue, very easy. And the important part is you don't have to do anything on the console, and as mentioned, copy around with some URLs, but you define just everything internally, and everything is handled by AWS SAM and also injected accordingly. So if you have to wait for a certain instance, AWS cares about this. If you update, for example, an instance, that you increase, for example, the allocated storage because you want to go from 10 gigabytes to 100 gigabytes, AWS takes care about this modification of the resource. You don't have to do it yourself. So there's no manual setup required, and everything is resources that are just interconnected and usable for you. So if we look at it from a development cycle, I would say right now. So you would start off developing and configuring what you actually use. So maybe you would start, I need a database in the beginning for my app. Okay, you just configure your database and start developing. You start developing, creating your first commands, maybe thinking, I have to add this road, this functionality, this service, whatever. Then just build it, deploy it. Everything is on AWS. Check it out. Oh, it's running, fine. Maybe it's not running, so you're reconfiguring, turning the cycle around. Everything is just modifying, adding, modifying, removing, and everything is handled by AWS SAM, so you don't have to care about anything else. So if you would look now how this would eventually look, if you're calling SAM build and you would have three functions, as in this case, the API function, a web function, and a queue function, these functions would be built and zipped by SAM build based on the configuration that we have made in the template level. Then you would be able to deploy it. If you have deployed once with a guided environment, the SAM config toml is created, which is basically the deployment configuration that is then available on the system and then can always be reused. You can also override, for example, an AWS profile because you want to use a different profile or deploy the same application to two different AWS environments because maybe for security reasons or whatever. You can even override the specific environment variables and inject something for testing purposes. So you are pretty much free to do a lot, and SAM takes care about the rest. So you're now deploying apps instead of functions. And if SAM deploys, you can check out everything that is actually happening with SAM. So SAM always asks for confirmation. So, or basically it asks for that in the default configuration, and you should never change it actually. So you can see where is everything uploaded, the S3 bucket. You can see what has been added as a resource, what has been modified as a resource, what else has been uploaded, for example. All these possibilities you have available and visible from the command line so that you can see what is really happening and can really confirm, yes, this is supposed to be deployed. So if we look at the deployment configuration, then the deployment configuration is pretty much very simple. It is exactly what you have entered when you first started a guided deployment via SAM. But the important part is you can have multiple different stages. So you basically have profiles here. So you can have a default profile, a dev profile, a staging profile, a production profile, and this is the important part. So you can have multiple deployments directly in one configuration without the requirement to have different files or different setups or different checkouts running. So if we would take the two files that we have right now, we have the template YAML, which is basically the infrastructure as code or the app as code, if you want to call it like this, and the SAM config toml, which is the deployment as code. So there are, of course, also some drawbacks. The example given is pretty much locked to AWS SAM or AWS in general. But we have split it up so good, I would say, that we can just exchange the mediator that we have here with the AWS SAM and introduce a different one, for example, for GCP or Azure or whatever we want to, via scripts or via other tools. So we created just an ops layer that we can exchange for something else to deploy our app that works locally and that works out of the box anyways to any other vendor. The other thing that we did, we introduced a framework. This framework offers us a lot on functionality and libraries that we potentially can use, but it also introduced some overhead, and the overhead can increase the boot and execution time of your serverless function. And this is important because every millisecond of reserved memory that you use from your serverless function costs, and costs can excel pretty heavily. But as you use existing frameworks have common optimizations, frameworks are normally known, and there's a lot of documentation. So in most cases, you can circumvent this overhead that you generate there, and it doesn't affect your serverless function too much, at least from my experience. So with all my advocating for serverless right now, everything could go serverless right now, right? But so if you ask yourself, do I need serverless? I would say no. So serverless is not the first idea to think about. As mentioned, think about your application. First, start developing your application. Then, with a big but, you can look at the pros and cons and think about if you should introduce a deployment to a serverless environment. It provides high availability and nearly endless scalability without the need of a big DevOps team. So really, this is bringing the developer back to operation who can maintain a fully running serverless application on its own. It's easy to start and scales with your customer, supporting peaks when you have, for example, marketing campaigns. So if you're ever in the lion's den, you're ready for it. You're only paying when it's running, and the availability is only given when it's running. So it's good if you have also maybe no traffic, no customers. It's not good, but at least then you are not paying. And I only gave you a glimpse about serverless deployments and serverless abilities right now. So there's much more to discover. So just go ahead. But on the opposite side, you have no insights into the infrastructure. This is good and bad. You don't want to care about the infrastructure, but this also limits you in the optimization that you have. You cannot care about servers, you cannot care about memory basically, or CPUs, or what hardware is used. This is all provided by the vendor that you're logging in. Costs can easily excel as a serverless on a serverless environment, as serverless really requires optimization because you're paying, as mentioned, for every millisecond in memory. And now, for example, if you set a timeout of, let's say, 5 minutes and you're reserving 1 GB of RAM and you have a failed, abort condition that is not hooking, and every time you're paying for 5 minutes, 1 GB. And this can be very, very expensive, very easily. So always think about monitoring, very important, and setting limits. The other thing is, if you have constantly running apps or constantly running endpoints, then maybe serverless is not the best because you're paying basically for every invocation of the serverless app. And maybe it's better to have it warmed up, have it caching, and have it running on normal instances and just scale in a more classic manner. The other thing is, you're only as scalable as the rest that you configure. If you configured resources like, for example, the smallest database available, then of course you might be able to catch 10 million requests because of an advertisement campaign, but your database cannot hold it. So the weakest part always defines your availability and scalability. And one important point in a serverless environment, you are limited to the computational resources that the vendor provides you. So for example, you can define a timeout and the memory size, but you cannot define the CPU amount, for example, in the AWS case, because with at the current state, with every 768 megabytes, you get 1 vCPU. So until you go over this limit of memory, you only have 1 vCPU. But if you need, for example, more vCPUs, you would have to increase the memory size. But with memory size, you again pay more money. And you have to decide if you want to go down that route or optimize your application. So this is a good and bad part. You are forced to optimize your application to reduce the memory and execution time. So now looking at the pros and cons, I cannot give you really a decisive answer if you should go serverless. The only thing I could say is just go. Just try it out. There are so many free tiers and free accounts that you could register for Microsoft, AWS, or whatever. Take the example that is provided on GitHub with this presentation and just try it out. Find out for yourself if this works out in your environment, if this is a good use case for your application. You know best what to do. But think about your application first and not the operation part. Serverless is only here to help you and not to dictate what you should do. Thanks a lot for your time.